Welcome to today's session. In this session, we will see how to build a classification model using decision tree algorithm for Titanic dataset. First, we will import the required libraries. So here I've used NumPy, Pandas, and machine learning library sklearn. In the previous session, we have already seen data exploration using Titanic dataset. So few section of this tutorial will be recap of what we have seen in that session. So first we will read the CSV data from the current directory using pd.readcsv. Then .dtypes will give us the data type of each variable. So here we have seen like p class and survived is of int, which is incorrect. Ideally, these are categorical variable. Boat, body, and home.destination. These three columns has to be removed. We would not be using for modeling exercise. So using del function, we will be removing the unnecessary column. And np.where will be used to correct the data type. Next, using dot describe function, we would print the summary stats of numeric values. Dot describe with parameter include equal to object gives out the summary stats of categorical columns. In this exercise, we are trying to build a model that would predict whether a passenger was survived or not. So our target class would be survived. So first we have to extract the target class into y variable. So y equal to target within braces survived dot values will extract all the values into y as an array. Next, we would understand the distribution of survived class. So this can be done using dot values count. So this will give out the count of each unique value. So here 0 that stands for perished has 809 passenger count and 1 survived is 500. First, we have to estimate the baseline model. Baseline model is nothing but the proportion of survived and perished. So that can be calculated using survived dot value underscore counts divided by total number of rows in the data set. So 0 is 61% and 1 is 38%. Whatever model we are building out, the accuracy should be better than this value. That is the benchmark which we have to achieve. Next, we have to do null value cleanup. So for age and fat, if the values are null, we'll be replacing it with mean values. Similarly, for embarked, wherever null value is present, we'll replace with S, that is the most frequent embarkment port. So we have done all the cleanup. Next, proceeding to the data enhancing. So first step is if the data has any categorical variable, we have to do one hot encoding. So one hot encoding is nothing but the process of converting the categorical variable into binary value. That is, one if category is present, otherwise 0. One hot encoding helps us to change the categorical value into numerical so that it can be provided to the ML algorithm, which are mainly mathematical function. So pd.get dummies within braces, we will give out value of all the categorical variables and use this optional parameter drop underscore first equal to true. The purpose of drop underscore first equal to true is, let's say for sex, it has two unique values. But to give the information whether a passenger is a male or female, it's enough if we have only one column. So wherever male is 0, that implicitly means female is 1. So it is enough if we have only one column. Next, we would create the independent variable x. We would drop the categorical variables and concatenate numerical value with dummy values. So now x has all the required input variables. Next, we will move on to the model creation steps. First, create the default decision tree model. Then, using test underscore test split, we would create test split of 30% test and 70% train. After that, dtc.fit within braces x underscore train and y underscore train. We will train the model using the training data and build a decision tree with these hyperparameters. So let's see what each hyperparameter means. Max step indicate the depth of the tree. Min sample split is the minimum number of samples required to split at an internal node. Min sample leaf, it is the minimum number of samples required to be at the leaf node. Max feature is the number of feature to be considered when we want a best split. And criterion is the measure of quality of split. Gini stands for Gini impurity, entropy for information gain. Minimum impurity decrease. So node will be split only if the split reduces the impurity by the threshold given in the value. So visit this URL for more details on each of the parameter. So next we will predict using etc.predict giving x underscore test value. Once the value is predicted, we will use the metrics such as accuracy, specificity to evaluate the model. So here dtc.score gives out the accuracy. This model has an accuracy of 80%. Metrics.confusion metrics will give out the true negative, false negative, and true positive values. We would expand the confusion matrix using the dot reveal function. Sensitivity of the model, that is the fraction of actual positive that are correctly classified, is 76%. And specificity of the model, that is the true negative rate, fraction of actual negatives that are correctly classified, 82%. And precision, what fraction of positive answers are correct, that is 75%. And we can use export underscore graph wiz to see the visualization of graph. So let's move on to the feature importance. So using the dtc.feature importance, we can create a for loop and iterate, print the feature importance ranking for each feature used in the model. So here we clearly see fair and gender and age plays an important role in predicting the output. So next we will do some feature engineering, increase the accuracy of the model. So as we have seen in the data exploration class, we would create three new variables. One is the family size, which is sum of sibling spouse plus parent child. Next is title, which will be extracted from name. The word which is just before the dot, and we will be grouping the rare title and sparse title into respective groups, and then create a new variable gender underscore child. If the age is less than 16, value will be child. If greater, then return the sex. Next, we would create get dummies for all the categorical values in the new data set. Then create the independent variable by dropping the categorical variable and concatenating the numerical values plus the dummy values. So x1 head will give out the new independent variable set. So once that is created, we would create a default decision tree classifier which gives out an accuracy of 78%. We will also see one more method, grid search CV. Grid search CV stands for grid search cross validation. So here it does two process. First is cross validation. Cross validation is process of training model using one set and testing with a different set. But it also does the cross validation in iteration. And then parameter tuning. Parameter tuning is the process of selecting the value for model's hyperparameter that maximizes the accuracy of model. Grid search CV is available in sklearn model selection package. So first we will create parameter grid dictionary by passing the list of possible values for each hyperparameter. So here I've used max depth and min sample leaf. Then create the decision tree model and create grid search CV with options estimator, provide the DT model object, parameter grid, pass in the parameter grid, CV cross validation iteration equal to 3, number of parallel jobs nil, and verbose equal to 2 will define the level of message being printed from the algorithm. So once we instantiate the grid search, so use gridser underscore search dot fit, pass the x1 train and y1 train. Then we can print the best parameter combination using grid underscore search dot best param. Best grid equal to grid underscore search dot best underscore estimator. Using best underscore grid, we can predict the values for test. The best values used are max depth equal to 3 and minimum sample underscore leaf equal to 2. Grid search dot score will give us the accuracy of the model, and here using the feature importance we can see which feature gives out the maximum information of the model. Here gender, child, male and P class 3 are important contributor for model output. So with this tutorial we have seen how to not only how to build a decision tree model but how to create new feature and use different techniques, grid search technique to identify best parameter, hyperparameter values for the model. Thank you.